بسم الله الرحمن الرحيم والصلاة والسلام على المبعوث رحمة للعالمين. Dear students, it's my pleasure to introduce the third chapter. Actually, this chapter contains three parts. We will start by part number 1. Here actually we are talking about distribution transformers. Application of distribution transformers. So this is chapter number 3. This is we can go through the web links and some other books as well. So distribution transformers, in general, distribution transformers are used to reduce. We are talking here on the secondary side. So here we reduce the primary system voltage. Can be 2.4 or 3, 4.5 and so on. So to convert it to utilization or low voltage 120 or 600 voltage. The following tables actually give the standard transformer capacity and the voltage rating according to ANSI. There are some designation for the transformers, and you have to understand what does it mean, this designation. This is according to ANSI standard. So other voltages are also available. For example, 2.4 here the cross has a significant mean. We will explain it later. For 7.2, which used on 2.4 systems, that is be changed later to 7.2. This table, this standard transformer kilovolt ampere and voltage. So here we have single phase, we have 3-phase rating, we have 5, we have 30. So for high voltage single phase or 3-phase, we have low voltage single phase or 3-phase. This is standard transformer. So here for single phase 5 kilovolt ampere or 30 kilovolt ampere as 3-phase, we have such this rating 2.4, 4.16, and actually when you see such slash, show here, it means we have delta connection and we have Y connections for this one. For 3-phase, we have only one connection, 2.4, and this means it is delta. So we have single phase, such as this designation 120/240. So we have 2 connections here, or 3 connections as well show. Here we have 3-phase for 208 and 120 for delta connection, for star connections, and here for center tap with neutral. So here for single phase 10, we have 3-phase 45. Have this designations. It means 4.8 for delta, 8.3 for the star connections. Here we have this star connection, and it means this is earthing, Y earthing. Also we can go through this rating. For example, such as this rates 13.2/22.8. This is for ground Y. This also, it means we have 12.4 star for 7.2. This is star earthed. This is star only connections. If we have like this one, this is delta connections and so on. Actually, these designations will be explained also on the next slides. For secondary symbols used are the letter Y. When we put Y, which indicates that the winding is connected or may be connected in Y, and ground Y, which indicates that the winding has one end grounding to the tank. If we have the tank, so we need the tank can be grounded. So we can take this grounding for making the Y connections to the tank, or brought out through a reduced insulation bushing, or we have bushing here, and also we have earthing through the bushing. So windings that are delta connected or maybe connected delta are designated by the voltage of the winding only. There is no any other connection, delta only. So to design a winding with emit the tap, which will provide half the full winding kilovolt ampere rating at half the full winding voltage. The full winding voltage is written first, followed by slant like this one, slant like this, and then the mid tap voltage. For example, if we rate 240 slash 120 is used for this, it means we have three wire connected to designate 120, three wire, 3 points like this, 3 tap. We have designated 120 like this one, mid tap voltage with 240 full winding voltage, 240 like this one, 240 like this one. So this is designations, it means such this connection. Here more explanation about what we mentioned before. Wind that is appropriate for a series, multiple, and three wire connection will have the designation of multiple voltage rating followed by a slant and the series voltage rating. For example, the notation as we mentioned 120 240 means the wind is appropriate either for 120 multiple connections, for 240 series connection, and for 240 120 three wire connections like this one. So we have another notations 120 240. The winding is appropriate either for 120, we can take 120 from here, multiple connections. Multiple connections, it means we can make like a parallel for the winding, make the circuit as a parallel circuit, and also we can take for 240 series connections like this one, series connection, and for 240 120 three wire connections as we mentioned like this one. So here more explanation about this one. So here for example, this we can connect for delta connection ABC. If we have for industrial, for example, here we have the input for the three winding like this one. So through the three winding we can connect the tabs like this one, or the leads, and make these connections as well. And these connections can be like this one. So we can here make multiple connections, maybe three phase, maybe single phase, and single phase for 120 and 240 and 120, and sometimes we can connect it for the center tap three winding like this one. Here we have connection, specific connection with 240 multiplied by 48. This is for the primary. For the secondary, we have 120 slash 240. So here we have many meaning actually. For 240 multiply for or cross 40 480 for the primary circuits. Here we can make, for example, for the voltage, if we have voltage 480, so the terminals H2 and H3 can be connected together, and we can obtain it H1 and H4. So if we make like raising, it will be better. Here we have to make some so we cannot obtain any eraser here for light, for example. So if I have H2 and H3 connected together like this one, so we can take the from H1 and H4. This is the first one. So when we get the connections for the input for the secondary 240, it means I have H1 and I have H3 connected together like this one. So I have H2 and H4 connected together, and I can take from H1 and H4 like this one. So this is the second connections. This is concerning the secondary, and this is the designation can be written as 240 cross 480. So for the secondary winding, so we have three connections. We have 24. We have 24 slash 120, we have 120. So for 24, so we can obtain X2 and X3 connected together like this one. So we can obtain from X1 and X4 like this one. 240 slash 120, it means X1 and X3 connected together. X1, X2, X3 connected together. And I can take three wires, X4, X2, and X3. So this is the center tab, three leads. So we have the final one, 120. 120, it means X1 multiple. X1 will be connected with X3, like this one, X1 with X3. X2 with X4, like this one. So we can take X1 with X4. This is like parallel connections. This is like parallel connection. So when I write 120, 24, it means we have three connections. Three connections, as we mentioned before, connection concerning 240, connections concerning 240 slash 120, and the connections 120. And for each connections, you can get this connections with X and the output leads. So when two voltage are separated by a cross, so a winding that is appropriate for both multiple and the series connection, but not for three wire connections indicated. So there is no three wire connections, or is if we put X like this one. Notation like 120 multiply 240 is used to differentiate windings that can be used for 120 multiple connection and 240 series connection. But once more, there is no three wire connections. Example, this is notation that's used here. Also, we have designation of voltage rating for single and three phase distribution transformer. If we have three phase designations like 120 slash 240, this means we have series, we have multiple, or three wire connections. So we have three connections for this one. If we have 240 slash 120, so we have three phase connections only. It means if we bring the high voltage first, so we have only two connections, series or three wire connections only. If we have 240 multiply 480, so we have series or multiple connections only. This is what means by crossing. So here also, if we have for the three phase 2.4 slash 4.2y, it means this is suitable for delta connection and also for y connections. If we have 4.2y, so this is only for y connections. If we have 4.2y 2.4, so we have y connection, and also we have neutral available, so it is given here 2.4. If we have 12.4 ground star and slash 4.2, it means we have y connections with the reduced insulation neutral available. If we have like this one 4.2, so we have delta connection only. So you have to understand what does it mean, these designations, and to read this notation. So to reduce installation costs to a minimum, small distribution transformer, we can use distribution transformer made of pole mounting in overhead distribution. It is more common to reduce the size and weight. So here to reduce the installation, we use pole mounting. But to reduce the size and weight, preferred oriented steel is commonly used in their construction. Transformers with rating 100 kilovolt ampere and below are attached directly to the pole, and the transformer larger than 100 up to 500 are hang on cross beams or supported lugs, something like this one. So if 3 or more transformer larger than 100 kilovolt ampere are used, they are installed in a platform supported by 2 poles. In underground distribution transformer, some places prefer the underground distribution transformers are installed in street vaults in manholes directly buried on paths at ground level or within building. This is for underground distribution. The type of transformers may be depend upon soil content, location, public acceptance, or costs. These some precautions to make such installation. The distribution transformers and any secondary service, junction service, are installed within element, usually based on either the front or the rear lot lines of the customer's premises. So this is the vaults, underground distribution transformers, like manhole, like this one. So this is underground. This more cross section here to more details about the fault connections or the underground transformers. So here's the low voltage cables, the high voltage cables. Here's there are the ladder, for example, lights for maintenance. Here there are some ground rod, here for outlet box, and so on. As we explained, this is underground distribution transformer, and this is preferred actually for many of cities, for specifically smart city. It's quite clear here. This is also underground distribution, complete substation, complete. Here, for example, the distribution transformer. Here some cables. Here also some cables. So this is underground distribution lines, and all the distribution substation underground, and here is a building. So this is specifically for the smart city. When you are prefer to work in the smart city, so prefer to prepare the underground distribution substation like this design or installation. Here are types of the distribution transformer. We have to classify to two types, dry type and liquid field type. The dry type distribution transformer, the methods of cooling through the air cooled or and air insulated, or there is air insulated. So the liquid field type of distribution transformer can be classified as filled with oil or indirect tin field. This is for specifically kind of transformer called like غاز خامل. Here example for the Onan. This is oil natural, air natural. So here is the core of the transformer. This is the tank. This is the radiator, and the radiator it means here is the air natural through the radiator from both sides. And here also the oil natural, there is no specifically any kind of insulation. So here the insulation is done through the oil, and the air and oil are natural for the cooling. This kinds of one of the cables, and actually this is a photo for such type. All the three phases are separate as shown in this figure. Here there are some categories for the distribution transformer. It is very important actually. The distribution transformer, there is some kinds of categories. We have conventional transformer. We have completely self-protecting called CSP transformers. And the last one is completely self-protecting for secondary banking transformers. So specific types of connections in the secondary, and it is very common. CSP are completely self-protecting for the secondary banking transformers. For the first one, conventional transformers. The conventional transformers have no integral lighting fault or overload protective devices provided as a part of the transformer. So here the transformers there is no any kind of protection. There is no also lightning arrestors, no overvoltage and so on. We have another kind, CSP transformers, are the name implies self-protecting. So here there are some kinds of protection like lightning or line surges, over voltage and short circuits. So this another kinds of transformer called CSP. Lightning arrestors mounted directly on the transformer tank, as shown in figures below, protect the primary winding against the lightning and line surges, something like this one. See, as shown in the figures, this is the main pushing, this is the lighting, this is the kinds of, like this one, transformers with two winding, and as we mentioned, there are many of connections like 120, 240, so we can make many of connections inside. So here this is the pushing, this is the lighting arrestors, this is on the for protecting. So overhead, this is called overhead pole mounted distribution transformer. This is single phase, completely self-protecting or conventional, and this is the three phase. This is called three phase. This is called single phase. Protecting or distribution transformer with the CSP. Here, as we mentioned, CSP types like this one, as we explained before. This is a conventional type, also another types. So here there is some conventional, some connections like winding like this one. It's very important to understand X1, X2, X3, and here we have two pushing, and the one is the central through the ground. In these types there is no any kinds of protection. For CSP type, as we mentioned before, we have some kinds of protection like lightning is this one. So overload protection is provided by circuit breakers inside the transformer. There are some kinds of protection. All these kinds of protections, you can find it inside this one. So the transformer is protected against internal fault by internal protective links located between the primary winding and the primary bushing. So single phase CSP transformer, this example oil inversed, maybe the cooling through the oil, pole mounted, the degree with 65. This is the frequency, this is the rating. Rating can be operated from 10 to 500 kV, are available for a range of primary voltage Here's a primary voltage of 2.4 or 34.4 kV. Secondary voltage are 120 and 240 or 240, 480 or 277. There are some kinds of operation or different voltage can be operated. Here actually more details about our single phase or three phase transformer which have protection element against. This is explained before. We have some kinds of protection. These units also have oil immersed. This more specification about the transformers. We have single phase transformer available in the following power rating. This is you have to understand the rating voltage. You have to understand this connection. You have to understand this connection. This is different power kilovolt ampere. Here another kind three-phase transformer are available in the following power rating. So see here some information about ANSI or IEC or GTC standards. So this you have to understand the standard or the different types of distribution transformer according to this standard ANSI, IEC or GTC. Here figures show more details inside the transformers. So here as we shown in figures, here's the bushing of the transformer. Here's the transformers connection. Here some protection lighting. Here also there are some bushing to bushing, and this is the connection of lighting to protect the primary winding. And so inside there is a protection and so on. This is some figures show the external. This is characteristics between the time and the currents for some kinds of transformers. Here actually single line diagram self-protected transformer show the surge arresters, the connections. There are some fuses, and this is the winding inside, so we can operating in different operating. This is the breakers. You have the breaker here. We have the breaker here. We have surge arresters for low voltage. We have surge arresters for the low voltage winding, and so on. This is a single line diagram, self-protecting transformers. So this is the main connections. The main connections of this the internal of the distribution transformer. This is actually three-phase pole mounting distribution. So to see maybe here in Oman you can see something like this one. So this is three-phase pole mounted distribution transformer. Here maybe this figures is very strange, but it is more common. I have seen in USA in Japan it is more common. This is maybe it is not nice figure, but actually I have seen it many kinds of these connections in USA and Japan. There are many of pole mounted distribution transformers. You can see it. It is not all figures, but it is also used in different countries. Here maybe we have special kinds of transformer, conventional self-protective transformers or breakers. Here distribution transformers are designed for banked secondary service. It means banked, it means we have different wind and we have separation using, for example, breakers. They are built similar to the CSP transformer, but they are provided with two sets of circuit breakers. Actually, two sets of circuit breakers connected in the winding. This is the second set is used to sectionalize the secondary when it is needed. So we have like backing. We have mainly secondary winding, and I have another secondary winding, and there is in between breakers. These breakers can be operated when we need to add some winding. It is very complicated, but it is very common in different countries used such as a type of CSCB. So here the second set is used to sectionalize. Sectionalize, it means when we need it For this winding, we can make switching using the breakers. Here actually it is very common. If you look here, there is the transformers. We have another transformers. We have another transformers, and here the winding inside. This is the primary. So here is connected, and we have many of winding here, and you can see here, for example, the transformer can make some sectionalizing to add some winding in the secondary. Actually, lamp flicker and the poor voltage regulation are among the other disadvantages of the radial system, which can make these connections of distribution transformer undesirable. So maybe if you have problems for flickers or voltage regulation, so these kinds of transformer cannot be used actually. The distribution transformer employed in underground distribution system can be. So here another categories for the distribution transformers when employed in underground. So we have some kinds called subway transformers. The other is low cost residential transformers, and this is the network transformers. Actually, it is very common in the distribution system. So now we have the distribution transformers for the categories that can be used in underground. It is very important if you ask questions, because we have many of categories now, categories according to the underground. So you can mention these three types. We have another categories like this one. So you have to be familiar by the distribution transformer are employed in overhead distribution system. Overhead distribution system can be categories. Don't forget these categories for the overhead distribution system. So there we are talking about the underground. So here also another kinds of types of the distribution transformer. So the distribution transformer can be classified for dry or liquid. So, and there are some kinds of dry and there are some kinds of liquid. Use the oil or in routine field. So here the categories of transformer classified in the liquid, here in the dry. So we have different kinds of distribution transformer. So we now have three different categories according to the distribution transformer, according to the cooling. Distribution transformer for overhead can be categorized, and here the last one is categories according to underground distribution transformers. So we have many different kinds of distribution transformers, and you be familiar by the questions as we can ask for underground, for overhead, for the cooling, and so on. So we have here, as you mentioned, the subway, low cost residential transformer, and the network transformer. Here we can show subway transformers are used in underground voltage, as we mentioned, voltage something inside. They can be conventional type or current protected type. So this is a subway transformer. So low-cost residential transformers are similar to this conventional transformer employed in overhead distribution. It is the same, but some kind of low-cost residential transformer. We have another type, network transformers. These are employed in the secondary network. They have the primary disconnecting and the grounding switch and the network protector mounted integrally on the transformer. So they can be either liquid filled or ventilated dry type or sealed filled type. Actually here there are some informations about network transformers with two different figures. So let's emphasize about the network transformers. It is very, very important. A company like ABB has completed the development of the dry type transformer intended for network applications. The unit is inside of a completely sealed tank, and both tank and active assembly have been designed and tested according to IEEE standard. Actually, here there are product scope, so you can understand the network transformers can be reached to 1 megavolt ampere, high voltage for 15 kV. We have different classes, we have different frequency, we have some kinds AN, air natural, so we have some kinds of partial discharge. It's very small. So here the network transformers, if you understand, we have here substation circuit breakers. We have, this is the primary, this is the primary. So from the primary to secondary, so here we can put the network transformer. This is the network transformer. If we put here, this is the volt, not volt, volt. So here inside this underground, of course, this is network transformer. As we mentioned, we have protection, network protector here. So here the loads, and this is underground. There are many of network transformers, and we can put this network transformers. So here we have different loads, and we have the connections of the network transformers. This may be example for the network transformer, as we mentioned, volt, something inside in the underground. So we have secondary cable, we have network protector, as we mentioned. This is of course the transformer. This is the high voltage switch. This is the primary cable. The primary cable like this one. This is the primary. This one. Here the duct lines. Here removable roof slabs, removable grating. So here the internal connections of network transformer, and it is very common and used, employed in the secondary. They have the primary disconnected and the grounding switch and the network protector mounted integrally. So as we explained, there are circuit breakers inside. This actually, the connections is very important. You have to keep it in your mind. You have to keep it in your mind, because I asked before about these connections and nobody answered it. So you have to understand the connection and how can we use it for underground. So finally, thank you so much for your concentration about these lectures, and see you in another lecture. Thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh.